Hi everyone! In today's video we will create RFM model using Python. RFM analysis is a concept used in data science and data analytics, especially in the marketing domain, for understanding and segmenting customers based on their buying behavior. If you don't know me, I'm Karina. I'm ex-finance person turned data analyst turned data scientist. RFM model stands for Recency, Frequency and Monetary Value. Using RFM analysis, business can assess customers based on recency, when was the last date of the purchase, frequency, how often your customers buy from you, and monetary value, how much they spend on your products. These three key metrics provide information to the business about customers' engagement, loyalty, and value to the business. So let's dig into it. Alright, let's start. I did RFM analysis in the past for a client, and you definitely can use this project not only for your data analytics, data science portfolio, but you can also find freelance customers, online retail companies, and do that for them. Today I will be using VS Code instead of usual Jupyter notebooks because I will be using Plotly library for visualization, and in my ordinary Jupyter notebooks Plotly behaves funnily, it doesn't display graphs, so I decided to stick to VS Code. All the visuals in today's project can be done using Matplotlib, Seaborn, or any other library. Usually I use Matplotlib, but I decided to spice it up and use Plotly today. I will be using online retail data from kaggle.com and link in the description. First of all, we need to install library, so pip install Plotly. I already have it installed, that's why requirements already satisfied. And also I had issues when I was creating visuals. It told me that I need to upgrade NB format. That's why we will also install this upgrade, pip install NB format upgrade. So just in case, so you don't have any problems. Now we will import several libraries. First of all, we need to import pandas to read our file. Import pandas spd. We also need to import datetime because we will be working with invoice dates. So import datetime sdt. And from Plotly we will import express, graph objects, and colors. So you need to import plotly.express spx, plotly.graphObject as go, and import plotly.colors. So when I was telling you what libraries to import, you actually need to change. So from datetime, you need to import datetime SDT and also comma time delta. So we need to import two things. Let's read our file. So we are creating a new data frame called data. Data equals pd.read_csv brackets. In the brackets, you need to indicate the path to your file. I'll just copy it. And let's print 5 top rows of our data to see what columns we have. Alright, so we have invoice number, stock code, description, quantity, invoice date, unit price, customer ID, and country. Let me quickly run as well tail, so bottom 5 rows of our data frame. Data, tail, brackets. Our invoices in this specific dataset starts in 2010 and ends in 2011. As a next step, we need to drop any missing values if we have any for customer IDs. Let's do data.dropNA brackets subset equals in which column we are checking if there are any missing values. So subset customer ID, comma, in place equals true. Now we need to convert our invoice date to datetime. We say data invoice date pd.toDateTime brackets data square brackets invoice date. And I will also create a new column which is total sales or total amount. It will be data square brackets total amount. So it's a total amount sold. It is a quantity multiplied by unit price. Let's run it. And now let's run again data head just to see how our data looks like. So we have this new total amount column. If you're working on this project as a freelancer, you're working with real data, then of course sales will not be 14-year-old. So in our case, why I ran .head.tail to show you that invoice date is 2011. So the purchases were made 13 years ago. For our RFM model, we need to see how recent the purchases were. And that's why we will create a reference date in ideal scenario. It should be today. So if we use real today minus purchase date, our dates will be 4000 because it will be 13-14 years. I will show you how to add a reference date as today's. It will be reference date equals pd.timestamp brackets dt.now brackets dot date brackets. So let's create it, and if we print it, you can see that today is 12th of June. So if you're doing this project as a freelancer, if you're working with the real data, your reference date should be today. But since we are working with dummy data, reference date will be different. My reference date will be maximum date in the data set plus 1 day. So we assume that the latest date was yesterday. In this case, reference date equals data square brackets invoice date dot max brackets plus time delta brackets days equal 1. And if we print this date, now reference date is 10th of December 2011. As a next step, we will calculate recency, frequency, and monetary value. Creating a new variable called RFM equals, we will group our data by customer ID. That's why we say data dot group by, in the brackets we say customer ID dot, we will aggregate to brackets, also curly brackets, and now we say invoice date So this will be the syntax, and let me explain it to you. First of all, we need to group our data by customer ID. That's why I say data.group by brackets customer ID. AGG is aggregation, so we will say that we will aggregate our data. And because we need to aggregate different columns differently, in the brackets I use curly brackets to create a dictionary, and this dictionary inside specifies which functions will apply to which column. First we say invoice date colon lambda x colon reference date minus x.max.days. So for each customer group, x is a series of invoice date values, all the transaction dates for this specific customer. X.max is find the most recent transaction date for this specific customer. Reference date minus x.max calculates the time difference between the reference date and the most recent transaction day. So it should be today minus transaction day, but in our case reference date is different. Dot days converts the time difference to the number of days. So the value will be number of days, 1, 3, 400, whatever. And lambda function effectively calculates the number of days since the customer's last purchase. Then we need to calculate frequency. So invoice number we are aggregating by count. So for each customer, this counts the number of invoice entries, how many invoices, how many purchases the customer made, how frequently this customer make purchases. And then we calculating the monetary value or total amount, we aggregating it as a sum. That's why we say total amount colon sum. So for each customer, this sums total amount of values and how much they spent with us. Let's run it. I recommend to rename those columns, so rename invoice date, invoice number, and total amount to recency, frequency, and value. To rename columns, we say rfm.rename brackets, in the brackets columns equal, and then we create a dictionary. Invoice date I will rename into recency, invoice number to frequency, and total amount to value, comma in place equals true. And again, let's review how our RFM looks now. This is how RFM looks like. So we have this recency, frequency, value. So we have a customer ID 12346, recency the last time this person purchased 326 days ago, frequency purchased twice, and a value 0, must be some test user. What about this customer? Recency 2 days ago, frequency 182 invoices for this specific customer, and this is the value the customer spent with us. Now I want to assign scores. So not only recency, frequency, value, but I will give a score to each of those values. Now we need to compute quantiles or percentiles for the recency, frequency, and monetary value. So we will create a new variable called quantiles equals rfm.quantile brackets q equals square brackets 0.25, 0.5, 0.75. So this computes the 25th percentile, so first quartile, 50th percentile, which is median, and 75th percentile, which is the third quartile for each column in RFM data frame. And now we will create a scoring function. When we create function in Python, we always define it, so def rscore brackets x, p, d. In this case, x is the value to be scored, so it's the customer's frequency, recency, and value. P is the column name, or which is again recency, frequency, value, and D is the data frame containing the quantiles. For frequency in monetary value, the logic is if x is less than or equal to the 25th percentile, we will return 1. If it's less or equal to 50th percentile, we return 2, and if it's less than or equal to 75th percentile, we return 3, and the rest is 4. So the big spenders get 4 points and little spenders get 1 point. Same for frequency. If the person buys many times, if it is a frequent customer, the score will be 4, and if the customer is not very frequent, we give him 1. But for recency, it should be in reverse order. So the most recent customer, where the value of recency is little, so for example, if it was 1 day ago, this person should get 4 points, while the person whose recency value, for example, is 300 days, so the latest purchase was a long time ago, this person should get only 1 point. That's why we have 2 parts in our function. So if our P equals recency, we score indifferently. So the most recent customers will get 4 points and the least recent customers get 1. While for frequency and monetary value, pointing system is different. Now we need to apply our functions to our values. So RFM square brackets R equals RFM square brackets recency dot apply brackets. In the brackets we say name of our function, which is rscore, comma args equals recency, comma quantiles, and we repeat the same for frequency and monetary value. And now let's display our RFM with RFM dot head brackets, and let's run this code. Okay, this is how our data looks like. So for example, our customer, this first one, not very recent, the last purchase was made 326 days ago, that's why recency score is 1, frequency twice, that's why also score is 1, and value 0, score is 1. And for example, this customer, recency only 2 days ago, that's why score is 4, frequency 182 times, again score is 4, and a value, high value, that's why score is 4. Now we will create a consolidated score, so we will combine all these RFM scores. RFM square brackets RFM segment equals, we converting our score to string, so RFM square brackets R dot S type bracket string plus the same for frequency and the same for value. And we also will calculate the RFM score, which is the total score. So we will sum up all this recency, frequency, monetary value scores into one big score. So obviously the highest number can be 12 because you can score 4, 4, and 4. So the highest will be 12, the lowest will be 3. It will be RFM square brackets RFM underscore score equals RFM double square brackets R, comma F, comma M, sum brackets axis 1. Let's run it. And again, let's display the RFM segments and see how our data looks. Here we are. So you see RFM. So this is a string representation of our scores. So this customer is a customer 111 and this customer is 444. Actually, at this stage, you already can stop the RFM analysis. So you've done the analysis, you applied the score, and now you can come back to the marketing department and say that you clustered, segmented all the customers based on their behavior, and now marketing department can come up with different strategies how to convert those not recent customers, not frequent, those 111s, how to convert them into current customers, and how to make sure that our 444 don't go anywhere because they are very sticky, loyal customers, so we want to cherish them. We want to give them special treatment to make sure that they stay with us, and then maybe our 2 to 4, so their monetary value is high, but they're not very recent and not very frequent. Maybe we want to give them special promotions. So you already have scores for all your customers. You can apply that to the whole database. And then it is up to marketing department to decide what to do with this information, what promotions to come up with. But we will continue our analysis. We will create a couple of more categories. We will create visuals which you can put together then for your portfolio or again to present. And if you work on this project as a freelancer, so then you can put together all of those findings in a beautiful presentation. Let's create labels. So we will create segment labels, low value, mid value, and high value. So I'm creating this segment labels equals square brackets, low value, mid value, comma, high value. And now we will create a function similar to the function we created before to assign those values based on a total score. So based on this RFM score, we will assign labels. So of course 12 will be high value and 3 will be low value. So our function will look like def assign underscore segment brackets score colon. So if score is less than 5, it will return low value. If our score is less than 9 and at the same time more than 4, it will return mid value. And for the rest of values, we return high value. Now we need to apply our assign segment function. So we say RFM square brackets, because we are creating a new column called RFM underscore segment underscore label equals RFM square brackets RFM score, because we use this column to deciding which label we want to apply. So we use RFM score column dot apply, and in the brackets we indicate the name of the function. And as always, let's review how RFM looks. When I work on projects, I like to display and print values to make sure that there are no errors, that everything goes as I planned. That's why I keep printing this dot head. So this is how our new column looks like. And now we can see it's, for example, person who has RFM score of 3 is a low value. Of course, this customer with 12 is a high value, 8 is mid value. Let's create a bar chart to see how many customers we have in each of those segments. So first of all, we will create a new variable called segment count, and we will just count all our customers in each of those segments. To do that, we say segment underscore counts equals RFM square brackets RFM segment label dot value count brackets dot reset index brackets. We naming our columns as RFM segment and count. To do that, we say segment underscore counts dot columns equals square brackets RFM segment comma count. And we will also sort our values based on RFM segment. Let's run it, no errors. And now we're creating our bar chart using Plotly. So to create a bar chart, we will say fig equals px or plotly dot bar brackets. Then we say what data we use, in our case segment accounts, comma, x-axis will be RFM segment, y-axis will be count. Then we indicate our title, which is customer distribution by RFM segment. We indicate all our labels, colors, and I picked these pastel colors to make something different compared to our videos. And of course, to display our visual, we need to say fig.show. Let's run it, and here how our bar chart looks like. So in high value we have almost 1700 customers, here we have almost 800 customers, and here 1900 customers in a mid value segment. We will divide our customers even into more segments. So what I'm suggesting, those customers where RFM score is more than 9, we will call them loyal customers, VIPs. You can call them champions, super loyal, whatever you want it to call, but basically it is the customers who have this highest score of recency, frequency, and value. So they're highly engaged, they purchase frequently, and they spend a lot. Then the next category or segment will be customers between 6 and 9. We will call them potentially loyal. These customers have moderately high scores, they engage, they have the potential to become champions if they continue to interact with a business. Then the next category is at risk, customers between 5 and 6. We will call those customers at risk because we think that they can churn if no action is taken and we don't re-engage them back. Customers between 4 and 5, we will say can't lose. These customers who have very low scores and they indicate that they are very close to be lost. They have infrequent purchases and low spending, and customers with a score less than 4, we can call them lost. It's those who don't buy often, don't spend much, not frequent customers. Even if we call them lost, they're not really lost for the company. They're still on your database. You still can engage with them and make sure they make another purchase from you. Alright, so let's create those new segments. We will create a new column called RFM customer segments for those segments. So RFM square brackets RFM underscore customer segment equals nothing at the moment, so it's an empty column. And then we will assign RFM segments based on the score. So rfm.log square brackets and then RFM score if it's more or equals 9. Then it will be VIP loyal, between 6 and 9 potential loyal, between 5 and 6 at risk, between 4 and 5 can't lose, and between 3 and 4 lost. Let's count the number of customers in each of those segments. So we will say segment underscore counts equals RFM square brackets RFM customer underscore segments dot value counts sort index brackets. Let's run it. Now we will create a new data frame to count occurrences of customers in each of those segments. Segment underscore product underscore counts equals RFM dot group by brackets. In the brackets we say RFM segment label comma RFM customer segments dot size brackets dot reset index and name equals count. Now we will sort our values by count, so it's our segment product count dot sort values brackets count dot ascending false. Let's run it, no errors. And now we will create another visual which is called a tree map. So it will show us those 3 segments where it's low value, high level, mid value, and then those values will split into extra segments, which is this VIP, at risk, lost, etc. To create the tree map in pyplot, we need to say px.treemap brackets, then we say which data we working with, in our case segment product counts, comma path. Then in a path we select a segment label and a customer segments. Our values will be count, our color will be RFM segment label, and then I again select this pastel color scheme, and then we select the title with RFM customer segments by value. And again, to display any visuals we use dot show brackets. This is how tree map looks like. If you worked with Power BI, you've probably seen these visuals before. We can see that in our high value, of course, we have all VIP loyal customers. In our mid value, now we split customers into potential loyal and at risk. So at risk we have 517 and a potential loyal is almost 1400. And then in our low value we probably have half of them are lost and half of them can't lose. Let's filter our data to include only our VIP customers. Let's create a box plot for recency, frequency and monetary value for these VIP loyal customers. In Plotly, this is how you create a box plot. So figure equals go.figure brackets, and then we will add trace. So we say from VIP segment recency, that will be our recency, obviously frequency, it's all obvious. And this is how our box plot looks like. We can see how many outliers for our value we have. Very interesting box plot for our value. So we can see that minimal value is 272 while maximum is 280,000. I wonder if this specific customer, is it some manual adjustment, is it a fraud, is it some error? So of course you need to do some more analysis before presenting all these findings to a customer, but very, very interesting. Let's also have a look at the correlation matrix. So we will create correlation matrix and we will say our VIP segment and then recency, frequency, monetary value correlation. and let's visualize our correlation. Let's create a heat map to visualize our correlation. And this is the syntax to create a heat map in pyplot. Color scale, I selected this RDBU. For that, I selected values. For X and Y, we select columns. I added a title, and to display, we say .show. Let's run it. So blue is a positive correlation and red is a negative correlation. On our heat map, we don't have any strong negative correlation because we don't have -1, but you can see that it's not as strong, but it is a negative correlation between recency and frequency. Okay, let's create a bar chart to look at all of those segments, I mean VIP and lost at risk customers together. So at first I'm selecting a pastel colors. So to define pastel colors, I say plotly.colors.qualitative.pastel, and then we're creating a bar chart with go.figure brackets. So I'm saying that I'm using segment counts index. I'm selecting a different color for our VIP customers, and then we will update traces. Parameters for our graphs, we're selecting a line color, a line width, and opacity, and of course we adding titles for x-axis, y-axis, and our chart title and fig show to show our visual. Here we are, we can see how many VIP customers we have. So looks like we have a lot of loyal customer base, and we have some who lost, some at risk, etc. And the last visual we will create today, we will do a bar graph where we compare all the recency frequency scores for different segments. So let's calculate the average recency frequency and value for each segment. So we will create a new variable called segment scores, and it will be rfm.group by our RFM customer segments, rfm.mean brackets reset index bracket. Then we will create a grouped bar chart to compare segment scores. To create a bar chart, we say fig equals go.figure brackets, and then we will add bars for our recency score. So with fig.add trace brackets, and here we say what is X and Y for our recency. Then we add name and a marker color, and then we repeat the same steps for our frequency score and now for monetary value score. After that, we updating our layout with .update layout. We add title, X-axis title, Y-axis title, and I also say to show legend, and bar mode is group, and of course to display the figure we do show. And this is the visual where we compare RFM scores for different segments based on RFM. Our at-risk customers, they are our recent customers, but not very frequent and don't spend much. Those who we can't lose, they are also very recent customers, but again frequency in monetary score is lower. The customers who are lost, they have 1 point in all of 3 scores, so they're not recent, not frequent, don't spend much. Our VIP, some of them not that recent, but you can see that they're obviously very frequent and spend a lot. And our potentially loyal, they're recent, but they are not so frequent. In this video there was a lot of script, so I didn't want to go into too many details of every parameter and everything I did, but if something was confusing, please let me know and I might explain it in a follow-up video. But you definitely can take this code and execute it for online customers. So if you know someone who runs a small business, you can suggest that you can work and you can develop this model for them. Maybe you can do it for free just for practice, or you can charge some small amount if you're just starting, or charge a lot if you are confident data analyst with a track record. It will definitely be very helpful for the person who you work for. If you know someone who has online store, who has some online business, this model is definitely something they would be interested in. So you can take this code, execute it, and it is a ready project. It's up to you just to put all the findings together into some clear presentation, add more visuals, explain what you've done, and your recommendations on what to do with all of these customers, but the code is here. I shared some secret code with you today. That's not exactly the code I use for my client, but the logic is there, it's very similar. So I hope you found this video useful, and I hope to see you next time.